we have Glenn Watson here this month, who is a Microsoft MVP, maintainer ReactiveUI, I think ex-Microsoft, I'm pretty sure ex-Microsoft. So Glenn knows all the peeps, super smart. And Glenn's been getting into this whole idea of GitHub Actions. So, you know, that's a pretty important thing for any application that we have. So unless anyone's got anything they want to raise, I might hand it over to you, Glenn, if you're ready.
Yeah.
All right, beautiful. All right, and actually, once we're done with that, you know, once we've had a discussion as well. Also, we'll have a little bit of chit chat and grab a drink after that session as well. But for now, let me stop sharing. Let Glenn share his screen, and a round of applause, and we'll welcome Glenn.
So everyone can see the nice, pretty screen with some graphics, I presume.
Beautiful.
So this is a very mishmash of sort of like slides that I put together, but it's going to go over most of the big details. So GitHub Actions kind of evolved from Azure DevOps. So basically your runners, the different, you know, like systems that run in the background that do the actions are based on Azure DevOps. So the software you find on the Azure DevOps CI is the same as what you find in GitHub Actions. But GitHub Actions is got some differences, quite nice ones, and some downsides. So I'll go over both of those. So this is stolen from their website. A few of these slides and stuff are. So it makes it easy to automate your software workflows. So CI, continuous integration, and continuous deployment. You can also build and test. But additionally, you can do, you know, automate your code reviews, your branch management, issuing, triaging. Basically, it allows you to hook into most GitHub events and then perform actions based on those. So it's slightly different to the Azure DevOps, which is very specialized. This allows you to hook into a lot more events, essentially, but they're only GitHub related. That's an important thing to remember. So the idea is you have an event, which will then trigger a job with steps inside of it, with actions, and then those actions will run on a runner. So be it Windows, Mac, Linux, or your own self-hosted runner. So that's essentially the workflow in terms of the way GitHub Actions will work. So the runners, just to start off with, you have your Windows Server, you have your Ubuntu-based servers, you have your Mac OS-based servers, and you also have Big Sur, so you've got your ARM-based stuff now as well. So that's pretty cool. So you can basically compile and get your code running on all these different platforms. So each runner will run on an Azure virtual machine. They'll basically be, when you have your event happen, they'll be quickly spawned up, and I'll have 2 cores of CPU, 7 gig of RAM, and 14 gig of solid state storage. The events can be based on webhook. So basically, GitHub might have a pull request has been open, closed, synchronized. It can be a scheduled event, so it can be, you know, like run it once a day, and also can be manual events, so you can trigger it manually. So these are all the webhooks, and this is probably more what you'd be doing quite often. So the common ones are pull requests and push. So they're your traditional CI style ones. So when someone submitted a pull request or synchronize it, or when there's been a commit push to your main repository, basically these will trigger off GitHub Actions. But there's a bunch of other ones here, like when a repo has been created or deleted, when an issue has been modified, when there's an issue comment. So for example, you could sort of like when a new issue is made, you could potentially label it automatically based on text in the header. That's a very common one as well. But you can hook into all these ones. And here's sort of like a workflow. So basically in GitHub Actions, there's a concept of a workflow. So a workflow is basically a YAML file, and it says what happens, what the event is, what the jobs are, where the job runs, what run it runs on, and then a bunch of steps that will be performed as part of an event. So in this case, we've got a workflow called .NET. It runs on the default branch, and it runs on either a push to the main branch or there's a pull request. And then it runs on Ubuntu, and then it basically has a checkout action. These user statements are basically GitHub repos. So that's referring to the username, that's referring to the repository. And basically there's a YAML file in there that says how that action will be performed. And everything is either a shell script or based on these actions inside of GitHub Actions. So let's continue. So we set up .NET. We set up .NET 3.1.301, so .NET Core. We do a .NET restore. We do a .NET build without a restore. And then we do a .NET test. So we do our unit test. So that's a very simple, common .NET workflow for pull requests and pushes. You can additionally have conditions. So in this example here, you can actually specify the types of pull requests. So these are the, if a pull request is open, synchronized, reopened, or closed. By default, I believe it's only open, synchronized, and reopened. I need it for some of my stuff a closed action as well. So I just copied that example into here. You can specify paths. So you can sort of like say, only run this action if you're in a, like if it's in the source directory and not the samples directory. I quite commonly do that, for example. So you might want to run different actions based on different directories. Like if you have an Android directory, you might want to do some post-processing, for example. And you can also restrict it to branches. So in this case, it's restricted to the main, but also tags as well. And you can sort of like set up workflow environment variables. These will be available for all jobs and steps. Each one of these, you can specify environmental variables, jobs, and steps. So let's go into a job now. So jobs effectively are a body of work. They are a bunch of steps. And jobs can be run in parallel, but they can also depend on another job. So for example, here we have job 1 that can immediately start. And then job 2 won't be able to start until job 1 has been completed. And job 3 won't be able to start until job 1 and 2 is completed. And they can also contain some like conditional system if statements. So this one is probably pretty hard to read. Basically says if we've got a pull request with a label called release, if it's a pull request and the pull request has been closed, and it's been merged. So this is a good example of putting a release tag on your pull request and then doing NuGet deploy is what I used it for example. So you could also specify variables that will generate, it's basically like a generic template in C#. So the idea is you would specify in a matrix, for example, run it on Mac, run it on Windows, run it on Ubuntu. Here's the Node versions, for example. And then each one of these jobs that relies as this matrix will be effectively run as a separate job. So I'll quickly show an example of this. It might be a bit easier. So if we go to my web browser quickly, and I'll zoom it up a bit, and then we can go to a recent pull request. And let's go maybe to this one. And then let's show the steps. So you can see here, there's been a debug and a release version. If we look at the file, and we go to the build samples, you can see here there's a matrix of configuration called debug and release, which is used later on in just in the MS build command script. And it's just setting the environment variable with configuration, which is based on the matrix. So effectively, that will run multiple jobs. So if we have a look in here and we go to the sample build, you can see in here, here's the jobs. So each one of these will run in parallel because I don't have any reliance on any other job. And so your debug and release will both compile at the same time, which is pretty cool. Let me go back to the power slide. So that's what that's demonstrating. Useful, as I said here, for different configurations, so release and debug, but also if you run around it on Mac OS and Windows, for example, you might want to run your project on both just to make sure it compiles well, which is important on projects like a ReactiveUI, for example. Each job will have steps inside of it, so they're just a series of different steps. They can have conditional environmental variables attached to them. They can either be shell-based actions, so they can run in PowerShell, Bash, command line, or they can include other GitHub repositories with predefined actions. And they can also output stuff out. So for example, I made my own GitHub action that scans through all the different commits you've had in Git and then generate release notes from that. So that allows you to input those, that output into another step. So for example, I might have a release step after my generate changelog, and that will then use that text as part of the release. So a good example of that is, let me go back to the example, and we'll just do, so I have a script that basically a TypeScript that goes off, finds all the commits, and then marks all the dependencies, or mark who made the change, just to acknowledge who they are. And then it will basically, based on the prefix, will put nice headings in for us. So Rodney here, for example, made some fixes. Well Better here Archer made some nice refactorings to the project, put some samples in, and there's some housekeeping stuff that I mainly did. So you can see it took a lot less effort out of the job by automating all this for me. So let's go back to the slide. Cool. And there's also a marketplace for different steps and actions. So here's a sort of like example of searching for .NET. You can see setting up .NET Core, and a bunch of people, it's open source, so a bunch of people making their own steps out there for you to absorb and use. At the beginning, GitHub suffered from a problem. There just wasn't much you could do with it, but now there's a ton of people contributing open source actions that you can take into your steps. So it definitely makes it more powerful. And you can make your own steps. So you can write them in either TypeScript or JavaScript, or you can use a Docker script. The disadvantage of Docker is it can only run on runners that are Linux-based. It would be nice if I had something like in Azure DevOps, you can include other workflows in your workflow. So for example, if you run like in my case, I have about 15 repositories that basically do the same thing over and over again. It'd be great just to in YAML file, say, go off and run all the steps that are in this shared file in like a central repository. That's not a concept yet in Actions, but it is in Azure DevOps. But you can specify starter templates for your GitHub rep organization. So what I mean by that is, let's go back to GitHub for a sec. Let's go to the Actions tab. You can specify, so see how here we've got a bunch of sample workflows that Google's provided for us. You can also kind of like have one for your organization level as well. So GitHub organization, in this case, would be ReactiveUI. So for example, it automatically detects what languages are commonly used in the repository and kind of suggest stuff. And you can base it off that, but you can also have organizational based ones. So, like if we click on there, create our step, it generates a dummy one for you, ready to go. So I've noticed there's some chat questions. Let's have a look quickly.
Oh, very good. I was just going to say, Paul had a question there about the YAML looking very similar to Azure pipelines.
Yeah, there's only minor differences. So, so if we go to this is not a good. There's actually one from GitHub themselves. It's slightly different, but it's very similar. But the advantage that Azure DevOps has over sort of like GitHub is Azure also has its own UI-based editor. In GitHub, you forced to use YAML, basically. But they are, GitHub Actions was formed from Azure DevOps and then grew from there. So there's definitely a lot of similarities because they are similar or based off the same code base. So there's some job usage limits in terms of your jobs. So in the free edition, you can have 20 concurrent jobs at once with 5 maximum for Mac OS. On the Pro edition, if you're a Pro GitHub user, you'll get 40 concurrent jobs with 5 Mac ones. If you're a team, you get 60 concurrent jobs, but Mac again, 5. Because with Mac, they have to use a physical machine, while with the other ones, they can use virtual machines. So that's why there's a little bit of a limit. And Enterprise is 180 concurrent jobs and 50. My experience, you'll probably never hit those limits on most average projects out there, but jobs can run for 6 hours. So you get a lot of time with your hours. You get 72 hours workflow runtime. So a workflow can be multiple jobs. So all those jobs will have a maximum of 72 hours before it'll cancel out on you. You can only make 1,000 API requests to GitHub per hour. So it means you can't spam GitHub basically. And with those job matrices where you could specify different variables that modify your job, you can have 256 mutations basically of your jobs per workflow. The costs, so for public repository, it's free. For the free level of GitHub, it's 2,000 hours actions minutes per month. So that's if you have a private repository. If you're on Team or Pro, it's 3,000 minutes per month. Enterprise, 50,000 minutes per month. And if you use a self-host, so if you run your own virtual machine somewhere or have your own physical device, you can self-host, which means you just tell GitHub where your machine is and you run a client on the machine. That's actually free. And additional minutes, Linux is the cheapest. It's, what is it? Many cents cheaper than, and in Windows, it's a bit more expensive. It's that price, and Mac OS is the most expensive. But again, self-hosting is free. One good thing to be aware of is Azure used to have one private runner that you get for free, and it didn't have any minutes associated with it, but they changed that recently to, I think, 1,600 minutes for free. So GitHub is actually cheaper now than Azure DevOps. I think they're trying to migrate people off, and probably they realized offering people unlimited number of runners was getting a bit expensive. So here I've kind of provided you with a kind of a, the comparison between the two. So Azure DevOps has private runners of 1,800 minutes per repository. Azure DevOps also has the idea of, has a UI for specifying your jobs, as I said. So, but with GitHub, you have to use YAML. You have no choice. Azure DevOps is more mature. There's a lot more actions out there. Given the open source nature of GitHub Actions, there's more developing. And the fact with GitHub, with DevOps, you kind of had to put your actions, if you wanted to use them at least with the UI side of it, you had to publish them. With GitHub Actions, you just need a repository, so you don't have to publish your private ones. And they obey organizational rules as well, so you can make your own actions and don't make them public to the world. And as long as if you're in the same organization, they'll be available to you. And the other advantage of potentially of Azure DevOps is it can use more than GitHub for source controls. But GitHub, you have to use GitHub. It's all around GitHub and nothing else. GitHub Actions is a lot easier on your repository key. So basically with the actions, your repository key is automatically shared. It's secure as well. All the GitHub Actions are run on GitHub's own infrastructure, and they've secured it up. The hosted devices are similar, if not the same, as Azure DevOps between GitHub. So the software is the same. They update them the same. GitHub uses the GitHub Actions for Marketplace. And the other main advantage of GitHub Actions is it can be used for more than just CI. So it can be used for any your common GitHub concept like issues in your and your pull requests and your wikis or whatever. As long as you can be webhooked enabled, it's usually available. And let's get to a demo, eh? So what I'm going to do is I'm going to steal Lachlan's. He's been making a sort of like a repository every month, demonstrating a concept that we talk about. So you can find it in Lachlan Gordon, Melbourne Xamarin Meetup, and he's basically put every month a little sample bit of code based on the concept that was talked about at that particular meeting. But he doesn't have any CI integrated with it at the moment, right? So I think he needs that. So let's just fork it off, and I'll just pop into my own repository. And let's take a few minutes. Any questions while I'm kind of waiting?
There's a couple in the chat, Glenn. Yeah. Sorry, Lachlan, you go for it, mate.
I was just going to say the same thing as you. Is there artifact storage in GitHub Actions? That came from Michael.
Yep. So let me. Yep, it's fairly similar to DevOps, but let's go over it quickly. So you can archive through an action. Again, it's basically a GitHub repo, and you specify a path where it can go. You can specify how long it's retained, for example. And a nice thing is you can share artifacts between jobs. So I will use that, for example, in the release repository. So if we go into my main build for one of our ReactiveUI projects. So the important thing here is I have an upload artifact at master, so the latest one. I call it NuGet, and I have a path to that NuGet directory, for example. So I upload all the NuGet packages generated by the CI, right? And then I have a concept of a release. So the release runs on needs build job, right? So we have a job called build all the way up here. And then I say it can only run if it's a pull request of a label called release. So basically let's do an example quickly. So I did one today. So you can see here, this pull request has a label called release. So that says to it, put those NuGet packages onto GitHub for me and generate a release. And one more back. And then, so I have that if statement, pull request, it has to be closed and has to be merged. So I don't want people closing a pull request and then suddenly be able to release it. Of course, that's a jump across. And then I can say download the packages. So I can download an artifact which matches the name from the create. And then I've got a bunch of stuff here for signing a NuGet package. I use my fancy little chain log generator, which has an output on it. And then I create a release. So this is going to create a GitHub release, has a GitHub token, has a tag name. So that comes through Nerdbank Git versioning, which is an automatic versioning tool. Again, I'll just use the same release name, and the body comes from my steps. So see how I've named my changelog steps? So I've given an ID. So what it does is grabs the output and then grabs commit log from it. And then I push it all the way up to NuGet. So I just do a NuGet push. So you can use it there as well, but you can also use it like traditional artifacts in terms of, you know, if I go into that build and I go into the action. Come on. And it didn't happen here. I want the build one, there we go. You can see now there's an artifact. And then there's the NuGet artifact, and I can download it like any other. So if you click on that, we should see we'll get a zip file down. Cool. So let's modify Mr. Lachlan's code. So I'm just going to bring that down. I am just going to do some command line stuff here just to bring it down. And then I'll share with you a okay, let me share that screen with you. Can everyone see this?
Yep.
I'll open a folder. All right, so the first thing you need to be aware of with GitHub Actions, they all belong in a folder called .github, which code is nice enough to tell us. And then they belong in a folder called workflows. And you can have multiple workflows per repository. There's no reason why you have to be restricted to one. And we call this build.yum. So the first thing I want to do is probably open up another window so I don't have to memorize all this. And give me a second, sorry. All right. So the first thing I want to do is give it a name. So we can call this build demo. And then we need to tell it what events we're interested in, right? So we're interested in probably the push event. And we're only interested in when it's the main branch. We're also interested when it's a pull request. And again, only interested in the main branch. You can specify multiple here, so you could say, and they usually they can use regexes as well. So you went. So this is going to be a simple CI job. So we're going to have a job, and we'll call it build demo, and we'll use a strategy. So this is that matrix feature I was talking about. So basically, we'll have two configurations, our debug and release. And then every, we'll say what it runs on. So in this case, let's do it on Windows. And then we'll get a bunch of steps in here. So our first step we can give steps a name, just to make it look nicer in the UI. So we can call it checkout. And then we can, in this case, we'll use the one that the nice people at GitHub have already provided to us. So it uses a GitHub action. And then you can specify a bunch of input variables. So you can specify, in this case, we're interested in which fetch def is 0. That's just a GitHub thing. And let's grab LFS, so large file storage. Just trying to work out what's combining that. I think this should be fine. I think we need to tab that out, that's all. There we go. So the nice thing, as you can see here, is your Visual Studio Code is actually aware of GitHub Actions. So automatically will tell you off and then give you nice warnings and stuff when you're doing something wrong. So now let's install .NET Core 3.1 or 3.1.x. We'll use, what do we call this one? So one thing to be aware of, these little @ symbols with V2, for example, are actually tags. So if we go to, let's have a look at repo. Let's look at this repo, for example, in GitHub. So if I share that screen with you, you just see it's just a normal GitHub repo. See the actions, checkouts there. And then we have different releases, right? So in here, we'll have different releases with our tag. So for when I'm saying the @ symbol v2, it's basically restricting it to this version here. And then a GitHub action is nothing more than a action.yml, which specifies what the action is, the inputs of the action, what it outputs. So for example, in this case, the name is checkout. It's got a description, it's got the repository we're interested in, but it's optional. And it defaults to a bunch of, there's predefined variables that GitHub offer out of the box. And they have a description which comes up automatically in the marketplace. So this is all about the marketplace, a reference. So that can be a tag, your branch, or your hash symbol. A token by default, it just uses a GitHub token, so you don't have to worry about it. You can use SSH, SSH stuff. It's got a bunch of path, cleaning, the fetch def, so the number of commits to fetch. So that's more for submodules and things like that. Large file storage stuff, submodules, if you want to check it out. And it says it runs on with node 12 and then run this script, basically. So if you go into the destination directory, this is basically a TypeScript file. So it's been compiled down to JavaScript. And that's the way most of these GitHub actions are kind of like expressed. So this is very ugly because it's transcompiled down, but if we go into the source directory, it's probably gonna, they've got a bunch of helpers for us. But that's the reason why we're using the @ symbol. So if we go back to our demo that we're making, so we're just locking it down to tag v2, locking this to tag v1, and we can specify those input variables. So in this case, we're interested in, let me go back to my sample just so I can. So we're just going to say install 3.1, and then the 3. The X just means wildcard, basically. And let's install .NET 5 as well, because I know Lachlan will want to probably adapt to .NET 5 in the future. So we'll say 5.0.x.
You betcha. Thank you for getting ahead.
The next step we want to use is, because he's got a, because this is a Xamarin project, you definitely want to set up msbuild.exe. So by default, it's not in the path. So what this does is basically say, set up the msbuild so it's in the path for you. And the last step we want to kind of run is sort of like just running and compiling the project. So we just run a standard off-the-shelf msbuild. So we'll call msbuild, and so this will run a shell script. It's up to the runner which one it uses, but you can actually specify which shell script it uses. So we could say use PowerShell, for example. Give me a second, I'll work out the syntax for that. It wasn't really. So we can say shell bash, for example. So we can actually say, run this on a bash script or PowerShell script or whatever. If you don't specify that, it will just run whatever it uses by default. We want the target of restore our NuGet packages and also build. So they'll both restore it and build it. We probably want to take advantage of the 2 CPUs that's on the server. Verbosity, we want it down to minimal, if I can spell. I probably can't. So this is a bit annoying with the large text. It's taking me a bit longer. We want to have the configuration. What we're going to do is we're going to actually set up an environment variable to point towards our configuration. So the configuration is set up in our matrix above. So we got our debug and release. And we just want to specify what project name did you call it? What's the solution name? Let's have a look. It's called Melbourne Blazor.
Changed a few times.
So we just call it Melbourne Xamarin. And then we'll grab our matrix and we'll put it as an environment variable. So that grabs our matrix value, pops in the configuration. So in theory, this is all we should need for a quick and dirty script, right? So let me check this in and we can go across and see how it looks. So I've just done the commit. And I'll just share that GitHub page with you. All right, so we got a little, that's a good sign. We got a little dot next to there that's indicating what the build action is doing. If we go across actions, well, that's looking promising. We've got something on our actions page. We can go into it. It's got a nice little, it's got two from our matrix. So it's got two builds running simultaneously with each other. And if we go into this one, it's setting it up. So let's see what happens. And usually takes a minute or two.
While that's running, we've got another question in the chat about Azure DevOps versus GitHub Actions versus Azure, Visual Studio App Center for building Xamarin apps. And there's been a bit of discussion in the chat already about it, but what's your take on choosing out of the three?
I would probably, I tend to lean towards GitHub just because for my purposes, it was one authentication mechanism. So all the projects that I work on are all GitHub orientated. So for me, and the other nice thing was for me was the automatic being able to do more stuff. And, you know, I was able to hook into GitHub information. So what I mean by that is I struggled a long time to have an automated system that other people other than myself could go in and automatically compile, automatically do a release for ReactiveUI. So someone had to have authentication inside of GitHub Actions, inside Azure DevOps, and they'd have to go in and log in. And the nice thing is I was able to get out the label information inside GitHub and use that information to determine if I could run a job. So it has much more ability to know all the GitHub state. And the other thing is when you make your own actions, and I'll go through an action with you in a minute, it allows you full access if you've got the correct repo code to all that information. So it allows you to get access to what the, you know, like what the commits are, that kind of thing. So, so that's my take on it, I guess. Let me see what that error is. So we have an error, and it doesn't like setup.net v1.
I think you've used action instead of actions.
Oh, yeah. Let's just check that in. So let's go into here. There we go. Did a quick commit. Let's have a look at it. So we just changed the text. And while we're waiting that to go, let's have a look at my own sort of like quick and easy ones I've made in the past. Let's do an easy one. So let's do like Sign Client. So Sign Client's a project of Claire Novatoni. She works at Microsoft in the .NET as a senior person. She wrote for the .NET Foundation a bunch of tools that automatically sign your NuGets for you. So basically, we could have one sort of like sign key for our NuGets, but we didn't have to know all the encryption details of it. We could just ask the sign client to sign it for us. And this is just a GitHub action that will invoke it for us. So in this one, I'll go through the sort of like the YAML that's automatically picked up. So you got the action. It's called sign client runner, runs that .NET global client. So it's just a global tool. You can specify the tool version. So if we look at NuGet.org, we go to sign client. It's just basically this tool here. It's just a .NET global tool. It indicates whether this follow symbolic links. So what the configuration file and a bunch of different parameters that sign client expects from the command line, right? And so if we go into the source folder, it's just a TypeScript folder. This one's fairly simple. It's just basically, here's a bunch of properties, what the configuration file is, what the files are interested in signing. So this is just using the a globber, what the base directory we want to go to, what the output directory is, a bunch of different stuff, some secrets and things like that.
While you're mentioning secrets there, we've got a question in the chat around, can you have secret environment variables that are not in the public GitHub repo?
Yep. So
how do they work?
There's two levels of that. So one is on your repository level. So you can add, they're fairly simple. They're basically key value. So it's a little bit annoying if you want to have like a binary file. You have to do a base 64 or something like that encoding and then pop it in here.
So if you've got the P12 and stuff.
Yeah, you base 64 at first and then pop it in here, which is what I've had to do, for example, with a lot of my personal stuff. I basically will have a, so for example, this one. So I have a secret in here, and it's basically a signing certificate and signing certificate hash, signing certificate password. The certificate is basically just base 64 encoded. And then I'll use it, for example, to do a release. This one's slightly different to the other one you saw, where it doesn't use sign client. It actually uses, I will get the PFX, I'll get the value. So the way you specify a secret is basically using a environment variable called signing certificate. See the secrets in front. So they're all matching up to that key value. And what I'm doing is just getting 64-bit string, base 64, writing it all out. I then load it up using PowerShell. Nice thing about PowerShell these days, it works on Linux as well. So it doesn't have to be just Windows. And then I just run NuGet and I do timestamper and say, run the certificate and then hash it all up. And then I'll use my changelog client and then I'll create a release and then I'll push it out. But that's how secrets will work. So there's two levels, organizational level. So you can have it all the way out here. And you could also have on the repository basis.
That sounds like a bit of a pain for the certificates compared to Azure DevOps and also App Center. You reckon they'll clean that up?
The other thing you can do, right? It's a little bit of a pain, but the other way you could do it is you could actually do like you can use Key Vault, for example. So people have made, Azure themselves have made a GitHub action that you can use to grab it from Key Vault for you. So you can use that to get your certificates, for example. And you can also, that's probably the easiest way. There's other, people have made like a bunch of helpers for importing in different certificates into the Apple system, for example. So I use this one when I'm using it for my own personal projects to sign Apple products, for example, gets it into their specific key store. So it's slightly more of a pain, but not, you can use Key Vault just like you can in Azure. I would love it if I had like an automatic base 64 encoder for you, or, you know, like, let's make a new secret, for example, just so people know what I'd love to have a just an upload file here as well, where you could do a value, but also just do an upload. I think that would be a lot of value, make it a lot easier. And then it just does the 64-bit base 64 encoding for you. So I'm still having. I see. It wants a platform as well. So let's change that. And I'm just going to put that up. All right, let's go back to that action I was showing you before while I've been jumping around a bit. Otherwise, I'll have to. So we got that manifest file, we got some TypeScript, we got just a setting file. GitHub gives you a lot of core functionality out of the box. So they have the ability to get an input from your GitHub action. So it's basically a name value and it gives you a string or whatever. And I've just done a bunch of JavaScript TypeScript things because, you know, like you don't know the type at this stage. At least TypeScript has the concept of types. And then they have a bunch of nice little actions scripts out there. So they have globbing, so file globbing. You got your standard TypeScript libraries out there and your core. And the core will give you the ability to talk to GitHub. And so I have this configuration file. I basically setting up this array of arguments I want to pass to a command line. And then I just build it up. And at the end, all I do is just run it. And then I will basically execute it. So on all the files that come from the globber. So they can be complex. The main disadvantage, I guess, is there's not many choices in languages, but that's true for Azure DevOps as well. If you've ever made an action for Azure DevOps, it's also TypeScript based. So let's see if we can get this action to work. And any other questions? That's basically my demo anyway. Anything else? Or is that a good enough demo for you guys?
That's pretty cool. We'll see if it builds. There's a question from Paul actually in the chat about, is there a way to use existing containers?
I haven't explored the containers too much just because my problem with them has been the fact that they're locked to Linux. So I often just go down the TypeScript route just because it's multi-platform. The Docker is very locked to Ubuntu runner, basically. There is another cool thing out there. There's actually a project for running so I probably should. I just can't remember the project's name. NextDOS Act, here we go. So providing your actions running on Linux, which now with .NET Core and .NET 5, it's a lot easier than it used to be. Active basically downloads your GitHub action, sets up a Docker image, and then runs your GitHub action for you, which is kind of cool. It's good for debugging quickly, which I find quite handy. But that doesn't really answer your question in terms of the Docker Hub stuff. I just don't know. And look, it's I believe that worked, or is that the wrong project? It's the wrong project. We'll keep it here and then I'll leave it to everyone else if no one else has any questions.
Do you know if there's any actions to either deploy to App Center or to any of the stores? Because I remember a while ago I had a look around and I couldn't find anything that was sort of official.
Yeah, there's nothing official, but there's definitely, I've done it, and there's definitely official actions in the marketplace that do work. So there's a couple out there now. But they are, here you go. Here's the official certified one. So it'll allow you to run your GitHub action. Hopefully I think that's more of an app than an action now, isn't it?
Yeah, there's an app and a distribute one, which is probably what you're after. The other question as well is there a concept of like being able to have somebody sort of dictate what, when something goes into a particular, like into production or into, QA or test, or you just set up a whole bunch of different builds, do you?
You could do it that way.
Like a gated check, essentially.
You can definitely, you have conditionals, right? So you could potentially, you could schedule stuff, right? So you could have like a, hang on. So you could have on a schedule, right? So you can use as a standard off-the-shelf cron syntax. So you could have a QA.yaml in your workflows directory that could upload it to a particular app center. And you could have another one that's, a live one based on every PR that goes in. You could do it that way. The other way you could do it is sort of like do it the same way I've been doing releases, right? You could lock it into a conditional that says when there's a release label on your GitHub PR do stuff, or you could have a QA one. So you could do it that way as well. And then you could, your jobs in general, your jobs can have conditionals, right? So, so you could do it like that. So you can get access to any of the event details.
Right, yeah.
And then you could do it based on, you could have QA there instead. And you could have different jobs that in here, you could have release QA, release. So you could have just a bunch of different jobs with conditionals there. I imagine would be an easy way to do that.
Yeah, cool.
This is looking better than it was. It's actually compiling stuff. And then I'll make a PR for lock-on, I guess, once this is done.
So once you've PR'd that YAML into my repo, if I just go in on, and if I accept it, if I just go in and click on actions and tell it there's the thing, that'll just run?
As soon as you merge it, well, as soon as I try to merge it in, because it's going to main, because I've got the pull request as an option there in the script, it will just automatically run. Awesome. You can limit that though. So see here, I've got when it's on main, when there's a pull request. If you want to stop allowing people from external repositories from running stuff on your server, you can just go to settings and see how at the moment it's allow all actions. You can say only when it's within my repository, for example. So there's a bunch of different options there. And here's how you can save your main artifact and log retentions. And also here's how you can add up your, your different runners and stuff. So you can say, I want to run on Linux, and it'll give you all the commands you need to write. And it has a little token to set it all up. So basically a bunch of command line scripts to get sorted out. But this could be a way of, like if you, one disadvantage of the pre-made installers, because they're actually pretty low spec, and they also generate when you're first setting them up. And the other thing is they've got to grab all those NuGet packages. It could be faster to have your own self-runner, but they do have a concept now of caching. There you go, it works for that one. So they have a concept now where you can cache off your NuGet packages into like an Azure store, and then automatically based on like a hash file being matched, it'll grab those. If it's different, if that directory is different, it'll grab the NuGet packages, and they've actually got a description how to do that in the docs. But I didn't find that too much speed advantage in doing that. But there is, every time you do a NuGet restore, it takes like 5 minutes because it has to grab all those NuGet packages over and over again. But that's also secure, right? Because if you've got a fresh, clean Docker image loaded up for every build, it means when you put your certificate on there, when it's automatically deleted, you don't have security issues.
Yeah.
So that's the reason why they do it that way for the cloud. But if you're controlling the process yourself for a private repository, it might be worth running your own self-runner. And that's the other thing to consider when you're doing self-runners is security. If you've got a public repo and you're doing self-runners and you're installing scripts and stuff, and you have that setting on accept all workflows running, someone could come along, make a GitHub action and email them your certificate and stuff, right? So that's stuff to be aware of if you're using your own self-runners.
With the self-runners or with something else, is there a way that you can kind of run your pipeline locally for debug purposes?
That's what that act can be useful for. So it's a command line tool that only works through Linux-based runners, but it'll basically run it on the command line for you.
Cool.
So it's pretty useful in terms of, it's easy to set up. You just run act and it will go off and run it for you. I found it useful. The other thing I tend to do is I tend to just use PRs a lot. So if I'm trying to get a, work out a bunch of how to get the script working, you saw even with the PR to your branch, I kind of will make a PR and just iterate on it. That's kind of useful a lot of the times. There you go. As Michael said, this is an easy way to get out of it. Hey? So there you go. It's in your repository now. So it should start firing off, I imagine. Maybe it might be security. It might not. You might not have that run all runners, so it might be picking up that you're getting an external. As soon as you merge that in, though, I think it'll start running.
Yeah, I'm just looking now. I was expecting it was going to kick off. I mean, there's a DevOps unit tests on that.
I didn't.
Looks like I've got something wrong in my Azure DevOps.
Yeah.
Anyway, I'm going to merge that pull request right away. Confirm merge.
But yeah, out of curiosity, how many people would adapt them? I'm just my feeling is if you're using GitHub a lot and you want access to all the GitHub metadata, this is the way to go. If you're using a lot of Azure key bolts and stuff like that, maybe sticking with Azure DevOps is probably better, but I think long-term, Microsoft probably wants to go this way, to be honest. Let's see if that worked, by the way. There you go. So you're getting an action kicking off. Congratulations, you now got a GitHub Actions on your repo.
Okay, Michael requests that you do his now.
Right.
I got a bunch as well you can do.
And there you go. So chit chat time, I guess, and talk about whatever you like.
Yeah, well, thanks, thanks, Glenn. That was awesome.
Yeah, I hope I inspired some people to join the GitHub revolution.
I can't see a reason not to. If I've got, I've got like a whole bunch of GitHub projects, just that I use for like mobile applications for my Twitch stream and stuff. I kind of can't see a reason why I shouldn't just throw a build around them. Just to keep them honest, basically. You know what I mean?
Yeah, and if you're doing public repositories like probably Lachlan, myself, yourself are doing, it's there's no downsides because you're not paying for it. If you're using private repositories, it's potentially cheaper than Azure DevOps as well. Actually, let me check the Azure DevOps pricing.
So while Glenn's doing that, if there's only a small group here, so if everyone wants to come off mute and ask some questions directly, that would be quite good.
About the talk, or?
Yes.
Ah, okay.
You're looking at pricing, were you, Glenn?
Yeah, so for a self-hosted instance, you have to pay $54.92 per extra host, while GitHub doesn't have that limitation. The only thing to be aware of is it's a little bit less transparent. So if we, I'm just trying to find, the website's a little bit more awful for Azure DevOps because I think they've just recently changed it to not have free private hosting. So you can see now it's 1,800 minutes with one self-host job, right? And that Microsoft job is, so the difference between GitHub here and Azure is Azure will only give you one runner at a time. GitHub will give you many up to 2,000 minutes per month before you get charged, while Microsoft will limit you to one concurrent job at a time with their DevOps product. So it'd be a lot quicker to get to your 2,000 minutes with potentially with GitHub Actions. The other problems are not really telling you, you know, like, you know, what the, I think basically you pay, here we go. So you get 1,800 minutes free now with Azure DevOps, but if you want to go above that, you got to pay per parallel job. So you get unlimited minutes with that job, but you pay per job. So you pay $54.92 per month per job. Well, GitHub, you pay additionally for your minutes, right? So you pay, I think it's 0.0002 per minute for Linux jobs. So it all depends on how many, you know, how much workflow you're doing for your jobs, right? So if you're doing a lot of processing, but you don't care about how fast it happens, then maybe Azure DevOps is a better pricing model for you, because it's $55 effectively for 1 month's job full usage. You can use it as much as you like, while with GitHub you're paying per minute.
Are they both still free, unlimited for open source?
Yeah, basically. So then the argument becomes a lot, you know, a lot more harder to gauge, right? So one disadvantage of GitHub versus Azure DevOps is Azure DevOps got a lot better private NuGet storage, right? GitHub packages is got some problems at the moment that they're fixing up. But one problem with GitHub Actions, GitHub packages is the fact that you can't access them without having credentials and a personal access token set up at the moment. While with Azure DevOps NuGet packages, you can have public access without any credentials. So. But for me, that's not a factor. I always publish the NuGet anyway.